In this video, I'm going to give a demo for creating a scatter plot. So now we want to plot time to maturity against yield to maturity. So I will just go ahead and select two columns here. And insert, check scatter plot. And then the next step is to check out the outliers. So all the data points is inside this graphs. So we can obviously see that there are 3 outliers here. So these are the bonds that with a maturity date that is greater than 80 years. So I'm gonna go ahead and check that. So basically it's these 3 data points here with time to maturity that is greater than 80 years. And for all other bonds, we have all of them with time to maturity less or equals to 35 years. So these 3, these are the outliers. So we don't want to include them into our regression. Okay, now the plot looks much nicer. So the next step is to add a fitted line. Now you can obviously see that this is not a linear regression. It's not a linear relation between both of them. So when I add the trend line, the default will be a linear regression. So I'm gonna try a polynomial. So I'm gonna check this and increase the order to 3. I'm going to display the equation on chart, also display the R squared to show the goodness of fit. And then finally, what is the model for yields as a function of time to maturity? And we can just copy and paste this regression here. Change it to yield. And therefore, this is our fitted line and also the model for yields as a function of time to maturity. And now we can use the model to estimate the cost of debt for Merck. And the average time to maturity of Merck is 7 years. So we can then use this regression model to calculate the cost of debt. Enter. Now the last thing I want to do, maybe I want to make this line more visible. So I'll just select the line here. Change the color. Now you'll be able to see that this is a pretty good fit for the data with R squared equals to 48%. Now, if you use the linear relation or other relation, you probably cannot get this high R squared. But if you increase the power here, we may have a higher R squared, but it's a mechanical relation. If we add a lot of X, the R squared will increase.